When it comes to solving problems involving weighted averages, the first four steps of the problem solving method, where we read the equation, define the variable, read the equation, and set up the equation, or read the problem and set up the equation, those first four are the most important and often the toughest part of these weighted average problems. Because solving these equations is easy. Writing in a sentence is easy. It's the figuring out how to set it up that's the problem. So we're going to use a lot of tables for this. So let's look at this first mixture problem. A tea company sells blended blackberry tea for $25 a pound. To make it, dried blackberries that cost $10.50 a pound are blended with black tea that costs $35 a pound. How many pounds of black tea should be added to 5 pounds of blackberries to make the tea? So we just read it. Second step, we need to define our variable. What is it asking? How many pounds of black tea should be added? So I'm going to say, let's make B the pounds of black tea added. So now that I've found what that variable, I'm going to use a chart to lay this out. And in my chart, I'm going to talk about the blackberries, the black tea, and the mixed tea. And I'm going to use the basic fact that the weight, or the pounds, times the cost per unit equals the total price. So let's see, B is the pounds of black tea that'll be added. So we know that that's going to go there. So we know that. Let's reread the problem and see what else we can figure out. A black tea company sells blended blackberry tea for $25 a pound. So we know that this right here, this cost of mixed tea, is $25 a pound. To make it, dried blackberries that cost $10.50 a pound, the blackberries cost $10.50, are blended with black tea that costs $35 a pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make the tea? So let's look at what we were able to get just from that read. We see that we're going to use 5 pounds of blackberries that cost $10.50 a pound. We're going to use B pounds of black tea that cost $35 a pound. And we know that the mixed tea costs $25 a pound. Well, if we're mixing these two together, how much mixed tea are we going to use? Well, it's going to be the 5 pounds of blackberries plus the B pounds of black tea. And if we multiply these, how much does it cost? This is 5 times $10.50. This is 35 times B. And this is 25 times B plus 5. All right. So now let's see. If we are taking the blackberries and the black tea and adding it together to find the mixed tea, we're going to set up our equation 5 times 10.50 plus 35b equals 25 times b plus 5. We took the weight and cost of the blackberries plus the weight and the cost of the black tea, and that's going to be the weight and the cost of our new mixed tea. And now we solve. So we see that 5 times 10.50, that's $52.50, so 52.5 plus 35b equals 25b plus 25 times 5, that's 125. Subtract 25 from both sides. 25b that is. So we'll have 52.5 plus 10b equals 125. We'll subtract 52.5 from both sides. And we'll see that 10b then equals 72.5. When we divide both sides by 10, we see that b equals 725. So b equals 725, which means that's the pounds of black tea added. We checked, does that answer the question? How many pounds of black tea should be added? Yes, we should add 7.25 pounds of black tea to the mix. All right, so we were careful about seeing what goes where when it comes to how we set up our box and then our equation. So let's look at this next one. Joy has 16 cups of punch that is 3% juice. She also has a punch that is 33% juice. How many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that is 20% juice? So let's see. We're going to be talking about 3% juice and 33% juice to get punch that is 20% juice. And we want to know how many cups we're going to mix, and then that will figure out how much total juice is in this punch. So let's see. So, what do we need to figure out first of all? How many cups of the 33% punch will she need to add? Let's just use X being the cups of 33% punch. So let's see, that X is the number of cups of 33% punch. And let's see, Joy has 16 cups of a punch that is 3% juice. She also has a punch that is 33% juice. How many cups of the 33% punch will she need to add to the 3% punch to get a punch that is 20% juice? Well, let's see, if we figure out how much juice there is, we have 3% or 0.03 times 16. We have 0.33 X, and let's see, if it's total cups, we're going to have 16 plus X, and when we multiply it, that's 0.2 times the group, 16 plus X. Now, how much is it going to be? Let's see, we add the 3% juice, so 0.03 times 16, to the 33% juice, 0.33X, and that equals our 20% juice, 0.2 times the group, 16 plus X. Now we multiply, and we see here this is 0.48 plus 0.33X equals, let's see, 0.2 times 1/6, that's 3.2 plus 0.2X, and subtract 0.48 from both sides. We'll get 0.33X equals 2.72 plus 0.2x, which then I'm going to subtract that 0.2x from both sides, and I'm going to get 0.13x equals 2.72. When I divide both sides by 0.13, I see that x equals 20, we'll round to say 20.9. About 20.9. Since things are really only in 1 or 2 decimal places, the rounding is fine. So x equals 22.9, that's the cups of 33% juice. Let's see, Joy should add 20.9 cups of 33% juice to get to the 20% punch. Alright, so really make sure we're thinking carefully about where these tables go, alright? These are tough, so rewatch if you have to. You can rewatch, that's okay. Make sure you really understand how these problems are set up. Now, if it took Matt 40 minutes to skate 5 miles, the return trip took him 30 minutes. What is his average speed? So it took him 40 minutes to skate 5 miles, and the return trip took him 30 minutes. So we know, hopefully from science or physics class, that distance equals rate times time. Well, let's see. I'm going to rewrite this equation looking for the rate, because we're talking about what his average speed was. So I'm going to say that r equals, when I divide both sides by t, d over t. Remember when we did literal equations yesterday or last night or this past couple days, something, whenever you did your video on literal equations? So we're going to use the fact that r equals t. So let's see. We know that it took Matt different speeds because it took him 40 minutes the first time to skate 5 miles. Then it took him 30 minutes to skate those 5 miles. So we're going to look for his average speed. So first we're going to find the rate of what it takes for him to go out there. His rate going out, let's see, was 5 miles over, let's see, 40 minutes. That's 2/3 of an hour. Which, when we do that, that means that it was 7.5, we'll use decimals, 7.5 miles per hour on the way out there. Now on his way back, the return, he did that same 5 miles in 30 minutes, which is half an hour, which means that he did that at 10 miles per hour. Now, because we're looking for the average, remember, we take the a weighted average, so we're going to proportionally find what his total was over how much time he spent. So we're going to look at his rate of going, which was 7.5 miles an hour. If we look at distance equals the rate times time, then we're going to see that the rate that he was going times the time, so that took him 40 minutes, but we're going to put that as a fraction. So 2/3 of an hour plus then his second rate, 10 miles an hour times his second time, which was half an hour or 30 minutes. If we put all of this over the sum of his top travel, 2/3 of an hour plus 1/2 of an hour, then we can solve for his average rate. So let's see, if we do 7.5 times 2/3, we see that that is 5 plus 10 times 1/2. That comes out to be 5 over, when we do 2/3 plus 1/2, that comes out to be 7/6. So 10 divided by 7/6. So 10 divided by 7/6. We see that his average speed was 8.57 something. I'm going to say that it was 8.6 miles per hour. So let's think about this. So we found what his going rate was, what his return rate was, and then we think this is what his average. Does that make sense? If it took him 7.5 miles going out, but 10 miles an hour coming back, does it make sense that it was about 8.6 miles an hour? It took him longer to go. He was going longer, this slower, so it does make sense that it is a little closer to that. So yeah, we'll say that Matt's average speed was about 8.6 miles per hour. Now, that was a little tricky. Those are tricky. We will work more on those in class. This one should make a little more sense. Two trains are 550 miles apart, heading toward each other on a parallel tracks. Train A is traveling east at 35 miles an hour, while train B travels west at 45 miles an hour. When will they pass each other? So let's see again. We said that train A is heading this way at 35 miles an hour. Train B is heading this way at 45 miles an hour, and they are a total of 550 miles apart. When will they cross paths? So let's see, we're going to set up another table. Well, what's the question? We are looking for when will they pass each other. So the T, we're going to look for T, time when they pass. And also remember that distance equals the rate times the time of something. So if we look in our table at train A and train B, and we look at the rate that they're traveling and how long they're traveling, that's going to tell us the distance that they travel. D equals RT, remember. So if train A is traveling at 35 miles an hour and train B is traveling at 45 miles an hour, Remember, they're traveling for the same amount of time. And so their distance, 35t and 45t. Now, how much do the two trains travel together? They start 550 miles apart, so that means that their total distance travel, when you take how much A travels and how much B travels, is going to be 550 miles. So we're going to take how much does A travel? 35t. Plus how much does B travel? 45t. And that's going to equal our total distance, 550t. So we're going to combine like terms and get 80t equals 550. Oh, sorry, there's no t here, my bad. Divide both sides by 80. And t we find when we do 550 divided by 80, we get 6.875. So that means that the trains will pass after 6.875 hours. Now we could be super fancy and figure out how much that is in minutes, which is about 6 hours and 52 minutes. But then we would just call ourselves nerds for figuring that out. All right, this was tough. I get it. Watch this video several times. Also, your homework on page 387, 1 through 5, is based on the examples that we just did. So I'm going to say, re-watch this video. Set up tables. Reread the problems. You can do it. Look at the examples that we did. We just made some great tables that'll be great ways for you to figure out how to solve these weighted average problems. Good luck. Ask questions tomorrow.